Welcome back, students. Okay, this is the beginning of Science 24 now. And I'm going to start with Unit B, not Unit A, because I don't have it built for online yet, and we'll have to do that at a later time. So this is Unit B, Lesson 1, Conversion of Energy. All right. Okay, we're going to talk about the law of conservation of energy again. And then we're going to trace energy transformation. Another thing we're going to do, maybe, because you guys are at home, but we're going to construct a simple model that transforms energy. That sounds fun. Okay, if we were in school together, I would go more into this, but you guys know the law of conservation of energy. Energy can neither be created nor destroyed. It can only be transformed from one form into another. Now, if we were in class together, I would talk about this machine here and Mr. Jewel, and there's some videos that you could watch, but I'm going to just skip over that for right now. If we were in class, I'd go over it, but we're going to make this a little easier. Okay, so let's talk about energy conversion in your automobile. We start with chemical energy. Now, that just means gasoline. So at the back of your car, you go to the gas, you stop at the gas station, you buy some gas. Gas goes, you put it back here, and it fills up this tank. Now, gasoline is just a big molecule, basically. I'll maybe draw it for you quick here. Gasoline, where can I draw this? Gasoline is a bunch of carbon atoms that are bonded together. 1, 2, 3, 4, 5, 6, 7, 8. I'm being a little simplistic here, but anyway, there's this big long molecule, and all of those dashes are connected to H's. So anyway, it's a big long molecule. Stored inside these bonds is energy. And when we burn the molecule, we get the energy out. So let me just erase all that. Okay, so I got chemical energy in the gasoline in the gas tank. So I got to get that gasoline up to the engine. So a pump pushes the gasoline, it goes into the engine. Once it's in the engine, it burns. And when it burns, there's pistons in this automobile that go up and down. And that is mechanical energy, movement, motion. So the chemicals made parts in the machine move. So chemical energy got converted to mechanical energy. And then, as you know, the engine gets hot. And that's when our little radiator kicks in, but the engine gets hot. That's thermal energy. And then, because the engine is hot and parts are moving, we can create electricity. And so the clock can come on and the lights in the car can come on. And then you can get light energy. So we can have energy coming out of the lights in there and the interior lights. So from the chemicals, we made motion energy, heat energy, electrical energy, and light energy. Okay? So that's some energy conversion. Okay, good. So chemical energy made heat, mechanical energy, electrical energy, and light energy. Now, the law of conservation is you can't create energy and you can't destroy it. You can convert it. So we converted from chemical into those other four. And it's balanced. Like that equals that. The amount of chemical energy equals the amount of light, electrical, mechanical, heat energy. Now, there is loss of energy in there too, but that would all be factored in. So the point is that we can't create it, we can't destroy it. The energy we start with is the energy we end up with, just in a different form. Okay? All right. Now, if you're you're watching this online, so I'll have links online. You can watch this balloon-powered water bottle, and we could make one of those. There's an elastic-powered one. And then just for fun, you should look at this. This is the coolest thing, this hydraulic excavator. A complex machine made of a bunch of simple machines that we learned about back in Science 14. Okay, let's talk about some energy fundamentals here. So energy is quite simply the ability to do work. It's measured in what we call joules, just like we measure mass in grams, we measure energy in joules, J. So you might have kilojoules or megajoules, okay? All right. And energy comes in two basic forms, potential or stored energy, and kinetic or movement energy, energy in motion. All right, so types of energy. I got potential energy. I've got kinetic energy. So I got stored energy, energy of motion. I can have chemical energy, like the gasoline is a chemical, and the energy is stored in bonds. Elastic energy, if you imagine an elastic band, when you stretch it out, you've just stored up some energy in it. Okay? Gravitational energy. If I have I'll just pause this. I have a cliff, a ball on the cliff. Just because of its height, it's got energy stored in it. If I then hit the ball and it goes over the edge, it releases its energy. So that's gravitational energy. Okay. We've got nuclear energy. There's energy stored inside the nucleus. I'm not even going to go into that. I won't ask any questions on that. Mechanical energy. So if objects are moving, even if you lift up your arm and put it down and lift it up and put it down, like you're lifting weights or something like that, the movement of your arm is like a mechanical device. That's mechanical energy. The parts inside of a car moving, like the pistons in an engine moving up and down, the wheels turning, that's mechanical energy. Okay, thermal energy is heat. You know about this, like in conduction, one particle bumps into another particle, and the faster they go, the hotter the object gets. Radiant energy, we've talked about that one. Electrical energy is the flow of electricity, which is electrons. Little tiny electrons are moving through copper wire. That's electricity. And sound. So when you talk, if you put your hand in front of your mouth as you're talking and just say something like, "Hello, Peter," you can feel the air coming out. You're actually pushing air as you talk. So sound is the movement of energy through substances like the air, and the particles are actually moving. So talk about compression waves here, but I'm not going to get into too much into the physics. Okay, so those are your 9 basic types of energy into 2 categories, potential and kinetic. Okay, now the fun part. We can create a vehicle that converts potential energy into kinetic energy, which would be sort of fun. And there's an example. That potential energy, which is the energy that would be stored inside the balloon, which is really a big elastic shaped into a balloon, right? It stretches just like an elastic. So elastic energy would get converted into the car shooting down the floor into mechanical energy. Okay. All right, so you could build this if you wanted. This is optional. You don't have to do this. You might not have materials at your house, but if you do, it might be kind of fun. So you'd have to draw a diagram of how you think your car would look. Consider that you need a chassis. That means a body, axles, wheels. Materials. You'd have to create a list of materials you need. For example, if we were in class, I would supply a pop bottle and some balloons and some elastics and tapes and straws. You'll have to just do it at home, so whatever materials you need. And you don't have to copy the one that the picture that I showed you on the previous slide. You can do your own thing. You'd have to write a procedure about how to construct your car. So that's an example of that is like saying, number 1, I cut holes in a plastic pop bottle. Number 2, and then, just write the procedure. How did you make your car? Okay, there's an important skill in taking the thing that you're doing with your hands and converting that into a procedure, a written procedure. Okay, because that takes some thinking, right? Take a picture of your finished car and then email it to me or put it on Google Classroom and submit it with this assignment. Okay, so there you are. There are some questions to do online, and that'll kind of quiz you on or how are you doing with mechanical energy or energy conversions. And it's not for marks, but you should do it just so that you know if you're doing it right or not. And if you want, go ahead and try to build a vehicle that converts potential energy into kinetic energy. Okay? All right. Have fun. I'm curious to see if anybody builds a cool little car. Okay. We'll see you next time. Thanks. Bye.